Alrighty, here we are. There's Buffy. Oh, you're probably wondering why I put Buffy on there. Because she's really Buffer the Vampire Slayer. See, you had the name wrong. This is additional aspects of blah, 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 blah. Chapter 17 we're still on. This is part 2. And I'm Ms. Bedrosian, of course. Going right to an example, a solution of NH3 is mixed with some NH4Cl. This is common ion, and we're going to see how it behaves. The major species are NH3, NH4+, Cl negative, and H2O. Cl negative and H2O, we can discard those. They're very weak. They don't really do anything. And the equation that we're really looking at is this. So taking a look at this just briefly, and let's do ice just to see where we are and where those numbers come from. So this is 0.25 from the solution, and this is 0.40 from that solution of ammonium chloride. And this starts out at 0. This becomes minus x, and plus x. So this is 0.25 minus x, and this one is 0.40 plus x. Be careful with it, that you get these numbers correct. And the last one, of course, is just x. You're going to be solving for POH and pH. Do that now. Here comes the answers. POH is 4.89. pH is 9.11. And you need to be aware that we're going to add an acid to this, a mild acid, 0.10 moles in 1 liter solution to this problem to see how it affects the pH. So now let's list the major species again, because now we can add one more to the list. And that is H+. Since HCl is a strong acid, it dissociates completely. So now the equation, what's really happening now, let's take a look, is NH3 plus H plus at equilibrium with NH4 plus. So that changes some things. So beforehand, this was 0.25 moles, but now this is 0.10 moles of that. And that ammonium, 0.40 moles, came from the NH4Cl. At the end, hydrogen ion will cause all of this to react. So we can minus 0.10 moles from the NH3 and conversely add that to the NH4 plus. So at equilibrium, we will have these numbers. This will be 0.15 moles. That will be 0. And this one will be 0.50 moles. Let's use our handy-dandy Henderson-Hasselbalch equation. If you recall, this is pH equals pKa plus log of the base over the acid, the concentrations of the base over the acid. In addition, let's look at Ka, which equals Kw over Kb, and plug those numbers in so we can solve for Ka. You can do that, and here's the answer. That comes out to 5.56 times 10 to the negative 10th. Well, if you know Ka, you can figure out pKa, which is 9.25. Go back to Henderson-Hasselbalch and plug it all in. And here it is, with those concentrations that we had there at equilibrium. Solving for pH, we get 8.73. Compare that to 9.11. Not such a big change. The buffer did its job. It is not such a big change. Here's a little kitty cat. And the pKa, well, the kitty cat is talking. The pKa of a weak acid used in a buffer should be close to the desired pH. This is how you figure out how to do it. In other words, a good buffer works when the concentration of the base divided by the acid equals 1. That makes a good buffer when they are close in concentration. So, as an example, if we want a buffered solution with a pH of 4, go back to our handy-dandy little equation. pH equals pKa plus the log of the base over the acid. Plug in 4 for pH equals pKa plus the log of 1. Therefore, 4 should equal pKa plus 0. Log of 1 is 0. So pKa equals 4. And so Ka is 1 times 10 to the negative 4th. This is for a weak acid. Hey, that works out. All right, this is your extra credit option. Caution, only the first person to hand it in who gets it right will get 3 points extra credit on the next test. First one, first right. So if you're the first person who handed it in and got it wrong, they get nothing. If you're the third person who handed it in and got it right, you get 3 points on your next test. This is the question. Find the change in pH when you have this many moles of HCl to 5 molar HC2H3O2 and 5 molar NaC2H3O2. There is the Ka, and I'm going to warn you, this is a secret. Don't tell anybody. No work, no points. First in, first right only will get 3 points extra credit. If you're not that person, you will not get extra credit. Okay? You have to hand it in first, and you have to be right to get the points. And nobody else is getting the points.